This is the brief on kinematics of helical motion. We're looking at what makes a perfect spiral movement possible. How an object can follow that smooth, continuous corkscrew path so predictably. First, let's talk about the trajectory itself. It's what we call a helical trajectory. Think of it as a mashup of two simpler movements happening at once. The object is spinning in a uniform circle, right? But at the exact same time, it's moving along a straight axis at a steady pace. Put them together, and you get that perfect spiral. Second, and this is the really cool part, the object's total speed never actually changes. Even with all that spinning and moving forward, its speed is constant. And it's all determined by just three things set at the start: how wide that spiral is, how fast it's spinning, and its steady forward velocity. Finally, why does that constant speed even matter? Well, it makes measuring the distance traveled incredibly straightforward. Since the speed doesn't change, the total distance, or arc length, is directly tied to the amount of time that's gone by. Simple as that. Ultimately, this predictable motion just confirms the reliable geometric consistency that makes such an efficient spiral path possible.